and welcome to Learn Rust. I'm Reese, and in this video we'll learn about shadowing and constants. Shadowing is the reuse of a variable's name. Here's an example. I want you to notice that in both instances where X is declared, it's immutable. There is no mute keyword. Thus, I have a question for you. Will this result in a compile time error, or will 25 be printed as output? Take your time. Okay, I'll build and run this code. The value of X is 25. If you recall a prior video in this series called Variables and Mutability, you'll know that immutable variables cannot be changed. Maybe a better way to remember it, though, is that immutable variables cannot mutate. The reason I'm not getting a compile time error is that I'm using the let keyword twice. These are actually two different variables because they're declared in two different let statements. The second variable shadows the first because these variables just so happen to share the same name, X. As programmers, we often refer to variables by their name or identifier, but in reality, this is only part of the variable. Don't believe me? Let's do an experiment. If these are in fact two different variables, then they should be associated with two different memory addresses. I'll add some printline macros and explain them. The ampersand next to the variable name indicates a reference. The ampersand is another way of saying address of. So ampersand X means give me the memory address associated with the variable identified by X. Remember, we covered memory addresses in the scalar types video. That leaves the :P in the curly brackets. You're probably wondering what that is. For now, all you need to know is that it's simply a way to tell the printline macro we're trying to print a memory address. Without the :P, printline will instead just print the value associated with X. Let's save and see what this program outputs. Indeed, these are two different memory addresses. You'll notice they're both in hexadecimal. Hexadecimal is used for human readability. Obviously, hexadecimal is more readable than binary, but also operating systems divide memory into segments. Our program's memory locations are offsets from said segments, which are easy to read as hexadecimal. This table illustrates what I'm talking about. Now, let's compare the memory addresses in the case of mutability. I'll add the mute keyword, and I'll use the shorthand for self-multiplication here. Note that there is no longer a second let statement. When we run this code, we see that the same memory address is output because the name X is referring to the same variable. Again, the name or identifier is only part of the variable. As such, the fact that we can reuse a variable's name is quite helpful. In this new example, it's even more clear that the name X ends up being associated with two different variables. The first type infers an I32, and the second type infers a string. As you can see, there are no compile time errors from running this code. Of course, this is a bit of a contrived example. There are real-world situations where it makes sense to reuse a variable's name, but normally you should use different descriptive names for different variables. Essentially, shadowing is not something I personally would often do. And if I do it, I will only opt for it in situations where it likely wouldn't confuse anyone reading my code, including me. That brings me to constants. Here we declare a constant called SUMConstant with the const keyword. And we declare another constant called another underscore constant. The naming convention is to capitalize all letters of a constant's name and to use underscores between words. This is also known as
Screaming Snake Case.
Note that SUMConstant is declared outside the function block in what is called the global scope. For now, all I'll say is that scope refers to a region where a variable or constant may be applicable. Relatedly, constants can be declared within expressions or scopes. If we run this code, you'll see it prints out 30,000 as expected. Now, the difference between constants and immutable variables may be nagging you. Why use one over the other? Well, one important distinction is that constants cannot be shadowed, unlike immutable variables. Once declared, a constant's name cannot be reused within the same scope. In that sense, it's truly constant. However, you can declare a constant of the same name in a separate scope. Constants apply on a scope-by-scope basis. To demonstrate this, let's reuse the SUMConstant name in a different scope. Now, what do you think the result will be? Will it work? Will there be an error? Let's find out. Upon running this code, I get a result of 21,000. And yet, I'm warned that the constant on line 1, SUM_constant, is never used. This is true. I'm not using it further in the program. But hey, let's try to fool the Rust compiler. What would happen if we added a print statement here? Alright, let's run this code. Now, wait a second. I'm still being warned that the SUM_constant declared on line 1 is unused, and SUM_constant within the function block is reported to be 1,000 before SUMConstant is declared here. How is this possible? Well, it's possible because not only are constants such as these confined to their scope, but also these constants are always evaluated at compile time. Alternatively, let statements can be evaluated at compile time, but not necessarily. Often, let statements are subject to runtime evaluation instead. Another thing to consider is that constants cannot be made mutable. Furthermore, they can only be declared with explicit type annotations, as I've shown here. I hope this video has clarified shadowing and constants versus immutable variables. We even learned a little bit about references and scope, but we'll go into much greater depth with those topics as we proceed. Right now, we're just getting our feet wet. Thanks for watching, and please like and subscribe.